Hey guys, today I want to talk about functions. Now, functions is something we haven't talked about yet, but it's going to branch off from our coordinate system to our relations to our functions. Now, so today we're going to compare relations versus functions. We're going to compare input versus output and independent variable versus a dependent variable. Now, yesterday we talked about one way to represent a relation, which is usually an ordered pair, is through a mapping. Okay. Now these mappings, some we could not make an ordered pair because we think of ordered pairs with numbers. But these bottom three we could make an ordered pair off of, and we could graph it. So if we look at this second one in the bottom middle, if I made an ordered pair, that would be 5, 2. 5 would be your x coordinate, 2 is your y. 7, 0, I'm just following the arrows. 8, 1, and 10, 2. Okay, so those would make my ordered pair. After that, I could go into a graph if I wanted to plot those points on a number or a coordinate plane. Now, a relation is a set of input and output values. Now, your input values are your x values. Your output values are your y values. Okay, if the output value is unique to the input, the relation is a function. So what they're meaning here is that if your x value only goes to a certain y value, then it's a function. Now, if I have the same x value, so I have two of them, but one goes to one number and one goes to a different number, then it's not unique, okay? And we'll look at an example here in a minute. So a relation is a set of input and output values, usually represented in ordered pairs. A function is a set of input and output values where the input value have only one output value. This kind of breaks down again your relation with your domain and your range. Okay, so if you need to pause that and read over that, you can. So it's kind of a review. Here's your function. A function is a set of ordered pairs in which each x element, or your x value, has only one y value associated with it. Therefore, it's a function. Look here. Okay, candy machine, a vending machine like we have in school. Okay, if you put your money in and you go over here and you select, she selected B14, then you're going to pick the snack that you want. So when you hit B14, it's going to give you the exact snack that you need. Now, when you go over here to this gumball machine, however, okay, when you put your quarter in, you have no idea what you're going to get. And so therefore, if you put a different quarter in, you're going to get a different prize, possibly. Maybe not, maybe so. But if you look in here, okay, you know you're going to repeat at some point. So this one is not a function, because every time you put a quarter in, you may actually repeat the output. Okay, the x values are your inputs, are your domain. So if you look at your ordered pair or your table, my domain here would be 0, 1, 2, 3, 4, and 5. If you look at your y values, or your range values, we're looking at the second number in each ordered pair. So we're looking at 16, 17.5, 19, 20.5, 22, and 23.5. Okay? Now, your x values here are considered your independent. Usually those are the values that we place into an equation, and we solve it for our y value, which makes it dependent. Y is usually dependent upon the x value. Now, let's look here at these two tables. Okay, so a relation says that x cannot go the same x cannot go to two different y's. So -3 goes to 7. -1 goes to 5. 0 goes to -2. We have a 5 that goes to 9, and we have a 5 that goes to a 3. So therefore, this is not a function any longer because I have a value of 5 that is going to two different y values. So there again, it is not a function. This one over here is a function because in the set of data that we have, none of my x values are repeating to a different y. Okay, we only have one of each, so therefore we know they go to one unique y. Okay, Now, the other thing you're going to have to do is you're going to be given an equation. Let's say we have the equation y equals 2x plus 1. Okay, and I'm going to ask you to make a table. All right, so what you're going to do is over here, you're going to tell me what your x values are. In this second spot, you're going to actually give me that equation, 2x plus 1. And then you're going to actually give me the y value over here. Then you're going to give me the ordered pair. Okay? So on our homework tonight now, you may have to add a different column or two there. But let's say we start with -2, -1, 0, 1, and 2. So you're just going to replace each x here with the number that we have on that line. So we have 2 times -2 plus 1. So 2 times -2 is -4. -4 plus 1 is -3. So that's my y value. Now my ordered pair is the x value, which was -2, and my y value. I'm going to do the same thing again, but this time we're going to go down and we're going to plug in the -1. So here we get -2 plus 1. That is -1. So my point is -1, -1. Here we're going to plug in a 0. So we know 2 times 0 is 0 plus 1. So my point is 0, 1. Plug in a 1. So my point would be 1, 3. And if I plugged in the last number, I would get 2, 5. Okay, so those would be my ordered pairs. Now, if I was to ask you at this point, is this a relation? You would look, at no point did my x values repeat. Now let's think about it. If I did this again and plugged in a -2, would I get a different y? No, I would not. So therefore, this is a function if you were asked about a function. All right, now after this, you're going to end up doing a notebook page, and you are going to do some homework sheets.